You put in dirty clothes. What do you get out?
Wet.
Clean and wet clothes. Okay. You have a toaster. You put in a piece of bread. You get out a toasted bread, a piece of toast. Okay. You maybe have an oven. You put in cookie dough. You get out cookies. Okay. Yes. Oh, I thought you had a question. Just kidding. Okay. So a function is like a machine. We have an input and we have an output. Okay? However, you know what? I did not know this was frozen. It's like I wrote page 59 up there for you. You can see it. Okay? So a function is a special type of machine. Okay? A function is a relation where each input has only one output. I'm going to let you write that down. And I don't think I've cleared up anything for you on what the heck a function is, what's a relation, what's an input and output when we are talking about math. Okay? Huh? That does say only one, but I forgot the E, didn't I?
Only has one output.
Only one output. So when we talk about input and output in terms of equations, our input is like our X and our output is like our Y. So functions can be described in a number of ways, okay? Maybe you have an equation, okay? Like maybe your equation is y equals x plus 7. If I input 1, my output would be 8. If I input 4, my output would be 11, okay? We can keep going on obnoxiously about that, okay? So that's what it would look like for an equation, okay? Now, I could give you an input-output table, okay? What does that look like? Basically, we have an XY chart, okay, where I have coordinates saying here's my X, here's my Y. Here's my X, here's its Y. So in this table, when my input is 1, my output is 2. When my input is 3, my output is 4. Okay. Using words, we could describe what's happening. Okay. A graph. Okay, I think we all know what a graph is, right? Okay. And we're going to talk about what's special about a graph, but I'm going to go ahead and just draw a graph right here. Okay, cute little graph. Okay. That is a function. Okay. Maybe I give you a set of ordered pairs. So it's kind of like this, right? This is an input-output table, okay? A set in ordered pairs is like, maybe I have like 1, 1, and 2, 4, and 3, 5, okay? That is like a set of ordered pairs. They're just listed as X comma Y, X comma Y, X comma Y. Okay, and I'm going to add one in here that they don't have, and I'm going to call it a mapping. Okay, what the heck is a mapping? I'm going to draw you one. Okay, so here are my x's, here are my y's, and I'm going to have these arrows that are like 1 gets mapped to 5, 2 gets mapped to 4, and 3 gets mapped to 6. So I know that my ordered pairs are 1, 5 because those are connected, 2, 4 because those are connected, and 3, 6 because those are connected. Okay. Okay, so let's talk about what this means in terms of a function. Each input has only one output. So every x has only one y. Okay, so I want you to look at this graph. We have this coordinate, this coordinate, this coordinate, this coordinate. Does every x coordinate have only one y coordinate? So is there a dot up there with x equals 4 that has a y coordinate besides 0? Okay, so here I have the coordinate 4, 0, right? Here I have the coordinate 3, 2. This is the coordinate 2, 4. This is the coordinate 1, 6. And this is the coordinate 8, 0. Okay, do any of those x's basically happen where, like, this x is 3 and its y value is 2. Is there another coordinate up here that has an x of 3 with a different y value? No. This guy, x is 2, y is 4. Is there another coordinate up there where x is 2 and y is something else? Okay, so this is a function because all of our x's have only one y. Okay, so if I wanted to describe this function in another way, let's talk about like what the mapping would look like. Like if we wanted to make a mapping, okay, my x values are, oh my goodness, Miss Holman, nobody stopped me there. What coordinate is this? This is 0, 8, and that's not what I wrote. Okay, so my x coordinates in that graph up there are 0, 1, 2, 3, and 4. Our y coordinates up there are what? 0, 2, 4, 6, 8, right? So what we can do is we can say, okay, I have the coordinate 0, 8. So I'm going to connect 0 and 8 with an arrow. We have the coordinate 1, 6. So I'm going to connect 1 and 6 with an arrow. 2 and 4 gets connected with an arrow. 3 and 2. 4 and 0. Oh, that's kind of pretty, isn't it? Derek doesn't care. Okay. David doesn't care. Dang it. Okay. We could also say, all right, well, I have a list of ordered pairs. I have 0, 8, 1, 6, 2, 4, 3, 2, and 4, 0. Isn't it way more efficient to do that mapping? I really like that mapping. I'm just going to throw that out there. Okay, so we've decided that if we have an x value that has only one y value, we have a function. So what I want you to do, I want you to come down here to a and b, and I want you to decide which one is a function and which one is not a function. Just the ones down here, a and b. Which means you have to talk to each other. Which one's a function, which one's not a function? All right. Is a function?
No.
I'm hearing yes and I'm hearing no. Okay. I see the coordinate x is 0, y is 8. Is there another x is 0 that has a different y?
No.
Okay, that's good. I see the coordinate 1, 8. Is there another x equals 1 that has a different y value?
No.
No. So every x has one y. So yes, this is a function.
I knew that.
Is b a function?
No.
No, the problem is x equals 8 has more than one y. Okay, x equals 8 has more than one y. Do you see that? Okay, every x can only have one y. So I want you to go to the next page, and I want you to determine C, D, E, and F. Which ones of those are functions and not functions? Remember, to be a function, every x has only one y.
C is not. 3 has 2.
I completely agree.
What? Ew. Yeah.
Say no. Okay, for D. Yeah.
I have no idea.
I'm saying.
I wish I heard a little bit more conversing between elbow partners here.
Oh yeah, so but this x has 2 y.
4 has 2 y's.
That was a very big.
I'm gonna say.
I didn't know.
I've practiced later. I'm not gonna make
Yes,
it.
it's easy.
You got a big game tomorrow, too.
I'm saying that because this.
Oh, I got a game
4,
tomorrow.
the 3 and 4x have.
Tomorrow's Thursday, right? We don't have anything on Friday or Monday.
Let's just wait for that one.
My cousin comes on Friday.
That's exciting.
Yeah.
From where?
Dallas.
Because x can only have one.
Yeah, x and y.
Because
But 3 and 4 have.
All right, let's talk about C. Rachel, what do you think? Function or not a function? All right, Rachel says not a function. Okay. David, what's the issue? Which input is the issue, David?
Wait. Oh, 3.
Okay, so 3 has 2 different outputs. Okay, that's not okay.
Yeah.
Okay. How about D? Miles, is this a function or not? Okay, not a function. There's a couple problems, right? Give me one input that's a problem. 5 is a problem. 5 has 2 different outputs. What's another problem, Em? 7 is also a problem. It has 2 different outputs. Okay? I want you to kind of like notice what that graph looks like at 5 and 7. Okay? Okay. How about E? Oh, I'm hearing yes, it's a function. Yeah. Okay, all of the X's have unique Y's. Love it. How about F? No, what is the problem? Okay. -1 has 2 different outputs. Okay. Okay. So I have a question. I want you to just think about these coordinates, right? 5 and 7 were a problem because they had two different y values. What's true about the dots? Okay, which direction? Up and down. Okay, so vertically, we see that those dots are a problem, right? I want you to imagine if we graphed these coordinates right here.
Same problem.
Same problem. Okay. So the first thing I want you to do on this page, okay? Okay, let's just talk about what a relation is, okay? A relation is a relationship with inputs and outputs, okay? I just want you to have this written down in case you ever need to like go back to your notes and you're like, what did we talk about that day? Okay. A function is a special relation where each input has one output. Okay. Now, when we have a list of coordinates, it's easy to pick out. When we have a list of really the mapping, it's kind of easy to pick out because you have an X that's mapped to two different places, okay? But what did you notice about the coordinates on the graph? Where were the problems when they were what?
They were not going up.
Well, they were like vertical of each other, right? Like that's the word that we used, okay? So we actually have what's called, and we're gonna write it here. We're gonna write the vertical line test right here so that you have it in your notes next to the word function. And then we are going to go to the next page and look at the visual of the vertical line test. Okay. So because we're dealing with functions, and functions, our inputs can only have one output. If an input has more than one output, those coordinates are going to be vertical of each other. So we have what's called the vertical line test. If we can take a vertical line and we can take that vertical line and move it through our function and it hits only once, we're good. But if we take that vertical line and we move it through, and even at one place, if it goes through more than one time, it fails the vertical line test and it's not a function. Okay. So like if I had a graph that looked like this. Okay. It's kind of a weird one, sorry. I know that right here we pass the vertical line test, right? If my vertical line is this blue one, we pass the vertical line test here. We pass it here, we pass it here. But what happens when I get to here? We go through it more than once. So we fail the vertical line test because we go through here and here. There's actually 3 places. Okay, so this fails the vertical line test. Okay, so this is not a function. Okay, so what I want, I drew that really crooked. Sorry, people. What I want you to do, I want you to go to the next page And I want you to answer 1, 2, 3, and 4. I have a really hard time with you interrupting my class for this. It needs to be at the end of our class, and if you forget, you need to come during passing period. Or wait till I'm done teaching.
Do your work. Laugh at me. You'll get me in more trouble. Zero. I did work.
You didn't have any work done.
I did.
Do you just want a 1, 2 or like 1, 2, 3, 4?
1, 2, 3, 4.
Okay, that's what I thought.
1, 2, 3, 4. What's this? I don't understand.
That's the x and y axis.
Oh.
Yeah. So then if you did the third one.
Oh, so it does work. You okay? Is his tiredness rubbing off on you, Ethan? All right, number 1, yes or no? Ugh, those darn -2's have more than one y value. All right, number 2, yes or no? Yes, all of our x's have one y. Number 3, yes or no? No. What's the problem? Okay. Number 4, yes or no? Yes. Okay. This is what's going to happen. You're going to test each other.